All right, welcome back. Today we are diving into a really powerful pattern that solves a headache pretty much every data engineer has faced. It's called Hybrid Stateful Polling. So yeah, let's get right into it.
So here's the big question, right? How do you keep all your data in sync without just, completely crushing your database? You've got your source database, you've got your data warehouse, and you need them to talk to each other constantly. But what's the smartest way to do that, especially when the perfect solution just isn't an option?
Okay, so the fancy term for this whole process is Change Data Capture, or CDC for short. And honestly, it's the absolute backbone of any modern data setup that needs to be close to real time. The whole idea is simple. You want to catch every single change, every new row, every update, every deletion, and get it over to where it needs to be fast.
Now, the absolute gold standard for CDC is something called log-based CDC. That's where you're literally reading the database's own private diary. It's transaction log. It's super fast, super comprehensive. But, and this is a big but, in the real world, you often just can't do that. You hit a wall. Maybe you're on a managed cloud database, or you only have a read-only access. It's just not possible. And that forces us to fall back on plan B, pulling the database with queries. So, okay, we have to use queries. What's the first thing you'd probably think of? The simplest, most straightforward way? Well, that's simple polling. And as we're about to see, its biggest strength, its simplicity, is also its biggest downfall.
The logic here is, well, it's dead simple. You just wait a set amount of time, say 10 seconds. Then you run a query to check for new stuff, and then you just repeat over and over and over. It's this really rigid, predictable loop, and honestly, it's where most people start when they first try to solve this problem.
I love this analogy. It's exactly like checking on a pizza in the oven. You set a timer for, say, every 10 minutes. You wait, you peek inside, and then you close the door and wait another 10 minutes. But think about it. What if the pizza's perfectly done just 2 minutes after you last looked? Well, tough luck. You're now stuck waiting another 8 minutes, and your data, or your pizza, is just sitting there getting cold. That's latency right there.
And that really gets to the heart of why simple polling is so wasteful. You're either checking way too often, hammering the database with useless queries when nothing has changed, or you're checking way too late, letting your data get stale. It's this constant trade-off, and you're never really getting it right. It's a total lose-lose, and it just does not scale.
So clearly, we need a much smarter way to do this. We can't just keep yanking the oven door open every 10 minutes. So what if we could build a more intelligent system? Well, it turns out we can, by combining a few really clever building blocks. This is where we see a total shift in thinking. On one side, you've got simple polling, which is just check every 10 seconds, no matter what. It's totally rigid. On the other side, you've got something way smarter, Backoff polling. The motto here is try, wait, try again, wait a little longer. It's adaptive and it's so much gentler on your database. So what does that actually look like? Well, check out this timeline. Your first attempt might be immediate. You find nothing. Okay, so for the next attempt, you'll wait, maybe 3 seconds. Still nothing? Fine, let's double that and wait 6 seconds, then 12, then 24, and so on. The wait time keeps growing, usually exponentially, every time you come up empty. This is genius because it stops you from bombarding a system that clearly has nothing new to tell you.
You know what this is like? It's like calling a super busy customer service line. You get a busy signal. What do? The dumb thing is to just hit redial, 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 right? The smart thing is to hang up, wait a minute, and then try again. Still busy? Okay, wait 5 minutes. You get smarter about it. Backoff polling is basically teaching our program to have that same kind of patience with the database. It's just respectful.
But, being gentle and patient is only half the puzzle. We also have to be reliable. We can't miss anything, and that's where our second key building block comes in. It's called Stateful Offset Tracking. All this means is that our system has a way to remember exactly where it left off.
And the best way to think about this is a bookmark in a book. Seriously, if you get interrupted while reading, maybe your job crashes or the system restarts, you don't have to go all the way back to page 1, right? No way! You just open to your bookmark and keep going. The offset is that bookmark for our data. It makes sure we never miss a single line, and we don't reread pages we've already finished.
Okay, so we've got our smart adaptive backoff logic. We've got our super reliable bookmarking. Now what happens when we put these pieces together and add just one more little ingredient for predictability? Well, that's when we get the ultimate solution, the hybrid pattern.
This whole hybrid pattern really stands on 3 core pillars. First, you've got cron-driven scheduling. That gives us a nice, predictable rhythm. Second, you've got our friend adaptive Backoff polling for all the intelligent retries. And third, of course, is the stateful offset tracking to make sure it's bulletproof. And when you mix these 3 things together, you really do get the best of all worlds. The schedule makes sure things happen predictably, the Backoff polling stops you from being wasteful, and the offset tracking means you never ever lose your place. It's a system that's robust, it's efficient, and it is seriously resilient.
All right, so we know the ingredients, but how does the recipe actually work? Let's walk through the whole workflow step by step, and you'll see exactly why this hybrid pattern is the absolute go-to when you can't get that ideal log-based CDC.
Okay, so here's the play-by-play. First, a scheduler, like Cron, kicks things off. Let's say it runs every 5 minutes. The very first thing the process does is it grabs its bookmark. It loads that last saved offset. Then, and only then, it starts that smart Backoff polling loop, looking for new data. If it finds something, great, it processes it. And here's the crucial part. It only saves the new bookmark after the data is processed successfully. Then the whole thing goes to sleep until the next scheduled run. Simple, right?
So when should you actually use this thing? Well, this pattern is an absolute lifesaver if you're working with cloud databases where you just can't get log access, or if you only have read-only permissions. It's perfect for that near real-time sweet spot where maybe a few minutes of latency is totally fine. But look, it's not a magic bullet for everything. If you need sub-second latency or you're dealing with just an insane fire hose of data changes, you really should still be fighting to get that log-based access. This is a fantastic, fantastic tool, but you got to use it for the right job.
So what's the big payoff? Well, it's 3 things really. You get low latency because that smart polling loop can find new data right at the beginning of its 5-minute window. You get amazing resource efficiency because it's not just spinning its wheels checking for nothing. And maybe most important of all, you get guaranteed progress. That bookmark, that stateful offset, makes the whole thing so resilient. Even if it fails, it just picks itself up and keeps moving forward.
So I guess I'll just leave you with this one question to think about. Is your data pipeline working hard or is it working smart? Because a simple polling pipeline, that thing is working hard. It's noisy, it's inefficient, it's kind of dumb. But the hybrid pattern, that's working smart. It's adaptive, it's resilient, and it's respectful of your systems. It's just a smarter way to build. Thanks so much for watching.